So now we're going to restart the situation, and this time we're going to set the initial velocity as 2 again and the mass as 4 of the left hand cart. So we'll put that in there. So again the momentum just stays the same. 4 multiplied 2 by 2 gives 8. But now the right hand cart we're going to give some velocity to. So we're going to set this as 1. Initial velocity of the right hand cart as 1. And the mass of the right hand cart we're going to keep the same as 5. So this time both the carts are going to have momentum. The left hand cart has momentum of 8 and the right hand cart has momentum of 5 multiplied by 1 this time, which is equal to 5. So the total momentum of the system this time is now 8 plus 5, which is 13. So what do we predict is the velocity of both carts stuck together. So the total momentum of the system now is 13. And we've got to divide that by the total mass. So that's 4 plus 5. Hasn't changed from the first run of experiment. So 13 divided by 9 gives 1.4. So we should see a velocity of 1.4 in here. Go. Is it going to catch it before the end? Is it going to catch it? Or just? Yes. Okay, so we got that correct again. So let's now start again. So you can see how useful this is to be able to predict what velocity two things are going to have when they join together after they've collided. So if we start again, and this time we're going to make the first left-hand one go a bit quicker. We're going to set that at 4, and we're going to have its mass at 4. That can stay the same. 4 and 4. So 4 multiplied by 4 is 16. So the left-hand cart is going to have a large momentum of 16 kilograms meters per second. The initial velocity of the right-hand car we're going to put at 1. So we're going to keep that as 1. But this time we're just going to change the mass up to 6. So we're going to have 1, 6. So this time we've got 6 multiplied by 1 gives us 6. And so the momentum now, total momentum, is 16 plus 6, which gives 22. And so the velocity of both carts after the collision is going to be 22 divided by 4 plus 6. 4 plus 6 is 10, so 22 divided by 10 is 2.2. So let's see if we've got... If we put 2.2 in here, 2.2 in here, make sure we've got 6 and 1. There, we've got 4 and 4, that looks good, so press go. Left hand cart shoots along, collides with the other one, they move off, and our prediction was right yet again, so physics is working. Were you ever in doubt? Okay, let's now go with an initial velocity of 4 and a mass of 4 for the left-hand cart. Keep that the same. So we've got a momentum of 16. And then for the right-hand cart, what we're going to do now is we're going to say, okay, we're going to ask the question, what happens now if the right-hand cart, instead of moving off to the right, what happens if it moves to the left? What